Hey guys, welcome to RC Video Reviews. Today we're taking a look at the ToolkitRC MC8. This is a sponsored video, so I'd like to say thanks to ToolkitRC for sending this little guy out for review. And it's a neat little device. It's a multifunction unit. It's got a lot of different little capabilities in a very small form factor. We're going to cover all of them. So I'm going to go up and down. I'm going to show you guys how this thing works. I'm going to show you all the little secrets. Well, almost all, like 99%. There's a couple things I can't do, but we'll talk about them. We'll explain them. So anyway, thanks to ToolkitRC for sending this little MC8 out for review. Let's get into it. I'll start out by letting you know at its core, and I'm going to zoom in a little bit. I got to get the radio out of the way, but at the core of it, it is a battery checker. I mean, that's really kind of what they're after initially with this thing. As you see on the side, it's got the ports right there for the battery. So you just take your LiPO battery, plug it in on the side, and when you do that, it'll bring up a little screen that'll give you your cell voltage. So sorry, I need to get my hands on a pointer. So there we go. There's the cell voltage, 3.8, 3.8, 3.8, all the way down on the 6-cell battery. And you can see it goes all the way up to 7 and 8 cells. So you can use an 8-cell battery on this if you need to. You also notice at the bottom there's some USB information. We'll talk a little bit about that, and we'll cover what that does for you in a little bit. But the first thing I wanted to do is get up and down on the balancing stuff. So right after you plug it in, you have the ability, as you can see here, to read your cell voltage, right, on a per cell basis. And then by this jog dial, if you long press a jog dial, when you do that, you'll see that some of these cell numbers highlight over on the side. And what that's basically telling you is the gray one is the low voltage cell. So that one's at 3.840. Everything else is higher than that. So when you see this orange, what it's doing is balancing those down to the lowest cell at 3.8, now 3.9. It's flickering a little bit. So that's the balancing feature on it, all right? You just simply plug in a battery, press the jog dial, and bam, you're right into a balance mode. So I think that's actually a pretty neat little feature. And that's really the core functionality of this device. So if that's what you came to see, you now know what you need to know, and feel free to take off. But if you want to see more about what this thing can do, let's cover that as well. So I'm going to give you a little tour of it. And on the top, you can see that you've got a USB-A and a USB-C output. You can see right here, there's a marquee on there, 5 volts at 1 amp. And then USB-C, it does USB-C power delivery. So I'd like to show you what that means. And I'll do that by giving you a look at a USB-C to USB-C cable. I'm just going to unwind that real quick. And I'm going to plug that into an iPad. I have an iPad Pro that uses a USB-C connector. So I'm going to plug one end of this thing right there into that iPad. There's my iPad Pro. And then on the other side, we'll plug it into the USB-C up top here. And the only thing we need now is power. So I'm just going to take this 6S battery and we'll plug it in, and that'll give us input power. And you'll see right at the bottom down here, you've got power delivery F. It's 12.2 volts. It's sending, at the moment, 5 amps to the iPad. That does go up. I verified it goes as high as 1.3 amps. I'll check the iPad charging status just to see. Yeah, it's at 92%, so it should actually rise. So I think there's probably a little bit of negotiation going on, but I have seen this go as high as 1.3 amps on my testing prior to the video. So anyway, there's USB-C out. And then you also, in the box, you get a USB-A to USB-A cable, and that allows you to do things like firmware upgrades. So you can plug this in on this side and then connect it to your computer, and you'll see a little disk drive up here, and you can drop firmware upgrades on the device when you need to do a firmware upgrade. And by the way, there is a firmware upgrade. I am running 1.02. That's available on the ToolkitRC website right now, and it does do a couple of extra little fixes. And then finally in the box, another thing you get is a little screen cover, screen protector there, and that's it. So anyway, there's the box, there's the USB-C portion. Now I want to show you one of the cool things about this that I think is enabled. I'm not 100% sure because I upgraded the firmware pretty quickly. But one of the really cool features on this is when you press a jog dial, just short press it, you notice that this field up top is highlighted in gray. And what that allows you to do is set a cutoff voltage for your charge device. So you plug in a battery, you don't want to get that thing, run down to 0 because the iPad will take it. The iPad doesn't care. It'll take whatever it needs. So you can set a cutoff voltage to keep your iPad your LiPO battery voltage safe on a per cell basis. It looks to me like in order for that to work, you need to plug in the balance lead connector, because otherwise how would it know? So if you just plug that in on the side right here. Sorry guys, this is a super short, I should have picked a better battery. This is a ridiculously short balance lead. It's for a quad battery, so I'm struggling with it a little bit. You normally don't have to deal with this, but there we go. All right, there. Now I've got it plugged in. Yeah, ridiculously short balance lead. Sorry about that. Okay, so we'll go back up here and we'll say, okay, we'll do the cutoff voltage and we'll set it to something below, you know, 3.85, or sorry, it's got to be higher than 3.85, doesn't it? We'll set it higher than 3.85. Let's see what it'll allow me to do here. 3.9. And what I expect to do is when you do that, you notice your voltage down here on the charger is now cut off. But if I go up top and change that to something below where I am right now at 3.85, then it should be resume charging the device that's plugged in. And might have to unplug and replug, but oh, it's making a liar out of me now. Oh, notice when I unplugged the balance lead, it went right back. So maybe it just determines it from this, I guess. I'm a little surprised at that. I would have thought that it would like to see the per pack voltage or per cell voltage, but apparently when the balance lead is plugged in, it does kill the charging output. Let's try that again. I just want to see that again. Now it's working. Okay, weird. I don't know. Weird little thing. Maybe a little glitch in the system or something, but there you go. Now the balance lead is plugged in. We can see we've got balance our per cell voltage over here on the side, and we've got our per cell cutoff right here, and we can see that the iPad is charging. So there you go. That's how you run it as a USB charger. And of course it'll work with a phone. If you have a lightning cable, for example, you can plug in your lightning cable right here and connect it to your iPhone or your smartphone, and that works just fine as well. Okay. So that's it on the USB function. There's also some servo testing functions and some receiver test functions, but I'll get into those in a minute. The next thing I wanted to do is show you guys how to calibrate these things, because it's important to understand how to do that. And we'll start out by, I'm going to show you my test rig for doing this. And this is very common on ToolkitRC products, right? The process is always the same. I'm going to zoom out just a little bit so I can give you guys a little bit of a better view of what's happening here. So here's my multimeter, and what I do with the multimeter is I create a little test lead, and what I do is I get a servo that's one of those extension servos, and I just cut the outer case off, and that leaves 2 pins, and that works perfectly for this type of device. And then my test leads go to an XT60 connector, and that lets me connect my probe leads from my voltmeter into the leads on this little test rig. Okay, so there's my layout. That's how you do it. A little ground wire on the top, a positive wire on the bottom, and that connects to your test leads on these alligator clips. Okay, so that's step number 1. Then we'll turn the multimeter on, and I'm going to zoom out even more because I want you guys to be able to see the whole deal here. And then the next thing we'll do is, in order to enter into the calibration mode, you have to press this jog dial. So press it and hold it, and while you're doing that, then you plug in your balance leads on the side. And you can see when you do that, it brings you into this little calibration menu. Okay, now the next thing we need to do is we're going to take our balance leads and we're going to, whoops, my multimeter leads just fell out on me, of course. The next thing we'll do is we're going to take our positive and negative terminal here, and negative, okay, so real quick, it depends on all your balance lead wiring can look different from mine. Sometimes they're multicolored, sometimes they're all single color, like this is black with one red wire. The red wire indicates positive, so negative is in this direction, and that also lines up with the marking on the device. So we're going to start at that end, and we're just going to simply connect. We're going to connect to that end, and I'm going to plug this one in, and we will take our little test lead and we'll plug in negative on the left, and all I'm doing is going in the back side of my balance connector. That's all I'm doing. We're just going to plug that in so we get metallic contact, and now we can read that on our voltmeter. And sometimes there we go 3.83. And what I want to show you on the ToolkitRC, and it looks like it's a little washed out, so I'm going to zoom in so you guys can see what I see on the screen. But notice on the multimeter, it's 3.83, okay? So we'll zoom in just a little bit, and hopefully I can get this thing to show you what's being read on the screen right here. Come on, focus camera, you can do it. It's not going to help me. Not going to help me, and this is going to be a real challenge to lift up so you guys can see it. There it is, 3.834 on cell number 1. So if you need to make an adjustment there, what you do is you'll hit the jog dial and you'll go down to that cell that you want to adjust and click the jog dial again, and then you can change the value on the ADC. So I'm reading 3.834 right now, and that's where I want to keep this particular cell. And that's it. So all you have to do to calibrate it is just take your probe out and move it down to the next pair of battery leads or balance leads, plug it in and get a reading. And on this one, it says, on my multimeter, it says 3.835. And that one on number 2 says 3.83. So that one needs a little bit of an adjustment. So I would adjust that up to match. It says 3.834 now. So I'm just going to spool that up just a little bit. There we go, 3.834. Now that perfectly matches my multimeter, which says 3.834. So you just keep doing that all the way down. You just move your pin and go down to the next one and so on until you're done. It's really important to calibrate these things too. I highly encourage that you guys do that. Don't just, I mean, they do a pretty good job getting them close to the factory, but get a multimeter you trust and test it out on there so you can see what's going on there. So anyway, there's the calibration process. And then when you're done, you want to make sure you go down to this section down here and hit save. And that'll write the values you manipulated into memory, and then you can hit exit, and that boots back into the operating system for the ToolkitRC. So there you go, that's how you calibrate, and that brings us to the next step, which is we're going to take a look at the servo options that you've got and the capabilities that it has with the SBUS and PWM. So what I'll do next is I'm just going to plug my battery in. And by the way, the input range on this, really nice. It's of course, my camera is just giving me all kinds of fits today. It's 7 to 35 volts on the input range. There it is, 7 to 35 volts on the input range. So you can use pretty much anything you want. I'll plug in a 6-cell battery. And then the next thing we'll do is notice on the side, there's a port here that says signal minus and plus, or sorry, signal plus and minus. So the plus is in the middle, signal's on top. This is a servo, one of my KST servos that's going to go on the Tron, and I'm just going to plug this in with the signal matching that arrangement. So signal wire goes on top, we'll plug that in, and now the next thing we can do is use the scroll dial, or the jog dial here on the device, and we'll go over to the measure, or sorry, we're going to output. That's what we want to do, is output PWM, and we will simply go ahead and use the slider here on the side, and we can move the slider to move the servo. What's cool about this is that they give you the pulse width right here on the screen. It says 16. I know that's hard to read. It's a little washed out. It's hard to get the camera to cooperate with the lighting. There you go, 1627. So what you can do if you want to do things like center your servos is just put it at, say, 15. There's 1499. Now that's one gripe I do have about this. There's no real deadband for center, and I think from a software standpoint, they need to introduce some deadband so you can find 1500 very easily. It's a little fiddly to get there. I'll tell you right now, it's kind of challenging to get it to land right at that mark. There's no mechanical center, and there's no software deadband that I can detect. So that's a little frustrating, of course, but it is what it is, I guess. I would encourage ToolkitRC to do things like that, make a deadband. The other thing that I noticed is if you change modes, even though you have that slider right in the center, if you change modes, the screen indicator goes back to a pulse width of 1000. So I'm not sure about that, because then you have to kind of move it. Once you move it all the way down, you can move it back up and it seems to calibrate it again. So that's another little anomaly that I saw. If you're doing something like servo centering, make sure you leave it right there on that screen while you're doing your testing. And here's the part that I was telling you. It's just a little fiddly. I've been lucky on the video so far getting it real close. There's 1499, and you can see there's center on the servo. So it's a nice little tool for that. I think very cool for that function. All right, the next thing I'll do that I want to show you is the output, or the input measurement. So the way I'm going to do that is I've got a Crossfire. This is a Crossfire Nano RX, and I'm going to plug that in, and I have this configured to do SBUS. So I'm going to plug this guy in right there, and then I'm going to use my slider and go over to the measure screen, and we need to change this from PWM to SBUS. So I told you earlier in the video, there are a couple things I wouldn't be able to do. PPM is one of them. I don't have any PPM receivers. PWM would simply be any PWM receiver that you've got. So any standard, fixed wing PWM receiver, that would measure your PWM pulses. In my case, I'm going to show you guys the SBUS pulse measure tool. And I'll tell you that there is seemingly some disagreement between top and bottom for this. So I'm going to set this, well, I can't set it down. Let me zoom out a little bit here. Okay, so what I did is I created a brand new model, and in my brand new model, there's no influence on inputs. So inputs are at 100%, the mixer is at 100%, and the outputs are all 100%. So if I bring up my channel monitor and look at my channel monitor, when I move this, we should see the typical 998 to 2012 on the output on the monitor. That's normal for Radio Master. But when I look at that on the little device here, we'll do aileron channel first. Notice that at center, ailerons are at 993, and then if I go full left, they're at 173, and if I go full right, they're at 1810. So you're not getting that normal, 1000 and 2000 range of 1500 in the center. I just want to point that out. And honestly, I think that's not that big of a deal, because really what we're doing is we're just looking to make sure when we use a device like this that our SBUS is actually working the way it should, so we can verify our channels. I guess, regarding these values, I'm not sure if those are intended to be microseconds or not. I get the sense that they're not, but in any event, what I can tell you is that at center stick, it's somewhere around 1000, and at full deflection, it's somewhere around 1810. And you can see that with my throttle. My throttle's all the way up, and that's 1810. Somewhere around center, we're at 1000, and then somewhere at 0, we're at 173 on the screen right there. So, like I said, the benefit in a device like this is you can validate that your SBUS is working the way it's supposed to, and that you have your channel assignments the right way. And I think that's good enough. Honestly, that's good enough. I wouldn't use a device like this to calibrate a flight computer anyway. I always calibrate on the flight computer itself. So that's that. Elias says 1499 or 1501. The splines on the servo horns are probably 30 to 50 wide, so it doesn't really matter. Yeah, that's true too, Elias. Yeah, he's accurate about that. Very good point. I did actually mean to say that, but I forgot. When you get that close to 1500 as the center, you can see which one is center, because the very next step on your servo is going to look something like that. So it'll be pretty obvious to you. But yeah, it would have been nice if they would have just put a software deadband. That's all. So there we go. That's it. I think we've covered everything. I'm just going to run through it real quick one more time. So on the input tester, you have the ability to check SBUS values. You have the ability to check, PWM and PPM. So those are your measurement capabilities on this device. And then once you've done that, you can use the scroll dial to do your balance work, your balance checking, and you can switch over to your output to set your output on a servo, so you can do things like servo centering or verify a full sweep, that kind of deal. So that is it. That's it on the MC8. It's a pretty cool little device. I like, as a battery checker, it's just fine. There's one other suggestion I would have for ToolkitRC if they watch these things, and that would be that if I leave the balance leads connected just on like that, go ahead and start balancing after 30 seconds. That'd be another cool feature. I mean, it's not that big of a deal to press the button. It's no big deal. You just press and hold, and it starts balancing your cells for you, which is awesome. But it'd be kind of cool if they would go ahead and activate that balance function if you just left your balance lead connected for a period. I think that'd be kind of cool. So sorry guys, I'm struggling with the back end of this cold, so I apologize for that. It was very sudden. I normally try and mute before making that kind of racket on a video. So anyway, there you go. There's a Toolkit MC8. Cool little device. I've got links in the description for Amazon if you want one. They're all over. They're in retailers all over. Banggood's got them. Amazon's got them. But yeah, you got your servo and your receiver measurement port there. You got cells 1 through 8 there. You have your battery XT60 input there. The slider to make adjustments for your pulse width out, and the scroll wheel to manipulate your menu selections and to get into your edit screen. And then on the top, you've got the USB-A and USB-C output, and that is USB-C power delivery. And don't forget to upgrade your firmware. They have 1.02 out there on the ToolkitRC website right now. So that's it. It looks like very little in terms of comments or questions. So John got in there first. Good job, John, on that, or Johan. And then Elias, glad you could join us, my friend. Boz, hi. Any news on updates on Edge TX? Well, you got to join the pilot jam for that, man. This is about the Toolkit MC8, not Edge tonight. Blake Terror, wow, I'm surprised you're endorsing a product with such terrible QC with high risk of real damage or danger to our fellow hobbyists. I wouldn't let any of my friends use one in their home. Well, that's too bad, Blake, because I got a news for you, man. My anecdotal or non-anecdotal evidence is that I use Toolkit products all the time. I use Toolkit chargers, I use Toolkit battery checkers, I use all kinds of their gear, and it's been pretty well flawless for me. So that to me is a pretty poor opinion because you're not supporting it with any evidence. Everything that I do is video evidence and proof on the channel, and I use this stuff. In fact, right there, that's the charger that I use at my desktop. It's got my leads for my power supply, and that power supply, by the way, the ToolkitRC power supply that they send out, that little P200, I've been using that thing for about 6 months. It powers my MacBook for me, and it runs my desktop chargers for me, and it works flawless. So you know what, man, I don't like that kind of comment because it's a blanket comment, and it's just not cool to say stuff like that because you're not backing it up with any evidence. So if you got an axe to grind it somewhere else, dude. I like ToolkitRC stuff. I think it works pretty well. All right. Well, hey guys, thanks for joining me on the review for the Toolkit MC8. Check them out if you want. They're about 35 bucks, so it's a little spendy for a battery checker, but it does a lot more than that. It's actually, I think this is kind of a cool little Swiss Army knife type tool that you can use in your toolkit for your field box or when you're building an airplane or a helicopter. Not a bad little device to have. Very handy, convenient, I'd say. I didn't really check the power output. I wouldn't really use it to do things like power an ESC or anything like that. But yeah, it seems like it's got some 5-volt power that you could use too by plugging in right there. So there you go. All right. Well, I hope you found the information useful, and I think that's all I've got for today. Hope you have a great day. Hope to see you on the Pilot Jam. Take it easy.